Hello, my name is Hanis, and today we're going to have our first STIA 1123 Programming 2 online class. We're going to start with Introduction to Object-Oriented Programming. So our learning objective today is to look into the basic concept of object-oriented programming. So during your Programming 1, STIA 1013, we have learned what we call as a structured programming. So in structured programming, your programming paradigm or your programming method is to have your codes running or to have your instruction running in a procedural way. So means that when you write your code and the code itself runs through a structured way. However, in programming 2, we're going to look more into what we call as an object-oriented programming, where we turn our programming code into what we call object. It basically translated a real world object into programming. Alright, so when we are writing a software, when we are writing a program, we are solving problems. And what we do is that when we design for any solution, we break it down into what we call as a manageable pieces. They are related to each other, and then we put it into these pieces, or we call it method or sometimes function. So when writing software, we design these separate pieces that are responsible for certain part of solution. So for example, if you are storing information about student information, so we have this method that storing information about the student only. Okay, you can put metric number, you can put names, you can put addresses, you can put whatever information that related to the student, and you can put it into one function or pieces or method, and we can call that method from our main program. So procedural versus object. So this is basically the two programming methods that are quite popular, but in a way, sometimes we do mix both programming together. So we have procedural and we do have object-oriented programming, but for programming 2, we are going to look into object-oriented programming in a great detail, and most of your programming or most of your project, assignment, labs, we are going to use object-oriented programming in that. So we know that when we develop a solution, when we develop a program, we divided the program into sub-problems. So these sub-problems, we define it or we develop it as procedure or methods. In Java, we call it as a method. And for procedural method, normally we define our method as a static method, because we need to be able to call that method easily from the main method, from the public static void main. And all these methods can be combined to solve our main problem. So procedure operate on data items that are separate from the procedures. So data items are commonly passed from one procedure to the other. So normally what we did is that we have this main data stored in the main program or the main method. And then from there we can call, or we can just transfer the data. We pass the data through passing function, passing method, procedure, and process that data inside that procedure, and then finally return it back to the main program. The separation of data and the procedure that operate on the data can lead to problem as program become larger and more complex. Okay, this is very, very true, because on a small scale program, when you have just a small amount of data, what we call as a manageable data, that is an easy thing to do. However, when you have data, or you have large amount of data, or your program started to become very, very complex, then you're going to have trouble managing the data, or even accessing the data, modifying the data, the value that that your program need to operate on. So it will become obvious to use another way of programming. So for example, let me create a new project, just a simple project to store just student information, right? Student info information, just a simple project called student information, and finish. Alright, so once we have this, in a structured or in a procedural programming, normally when we like to have our program to store user information, so normally we can just we can request the information from our main method. So for example, variable name and metric, and maybe one more phone number. So we have these three variables that we like to store information, and then we need to request from user. So we need to use scanner class. System.out.println, enter student name, and then we assign the value, the variable, to the scanner object, and then for metric the same. So 1 2, another 1 3, and then enter student metric, and then for this we have metric number, and finally phone scanner dot. Okay, so if you like to print back the value, name plus name, metric plus metric, and finally phone plus phone. Okay, so this is just a simple data. So when you run the program will request for student name, student metric number, and finally student phone number, and then print it back to the terminal. So simple as that. And you can also break it down into a functions, or what we call as method. So we can call static void give it student request student info method name, and then we can have our method passing value string n, string m, and string p, representing name, metric, and phone. And then we can have all this to be put into this method, because the idea is we want to break it down and then name, metric, and phone, and then we need to call this Alright, so if you like to break it down, so for example here the variable from our main method here, and I would like to print the information on a separate method. So you can do that by having a static method. Okay, you can only use static void, for example, print student info. Okay, so you need to submit 3 variables. So for example, we have 3 variables here called name, metric, and phone. So string name, string metric, and string phone inside here. And then if you like to print that value and then put it the print information here. Okay, so we like to print, call the method print student information with name, metric, and phone. Okay, so this method is a static method, so we can pass the value, the 3 value that we get from here, from user, and then print that information inside here. So every time we call for this method, we can pass this 3 variable and then print that variable in this using this method. Okay, so if you run this is basically going to produce the same output, and is metric number, phone number. So you get the information print back. That is basically the idea, okay, behind procedural programming. So we divided our problem into subtasks, or sometimes we call it procedure or methods, and the data item that are separate from the procedure commonly can be passed from one to the other. So here I'm breaking the problems into subtasks called print student info, and then you can have the information print back to user. So this is basically how structured programming works. However, if you like to grow this program, or you like to have this program to accept more information, okay, so you need to use a much more complex data structure such as array. Yeah, because for this you can only accept one variable at a time, one value at a time. So you might need to use array that will help you to store information, more information into your application. So with that in mind, we can add more program or more we can add the array back into our program. So if you still remember your array, so you need to set your array and you need to define your array size. One thing to note, if you didn't use array, you need to use more variable here to store the information. And for example, you want to store the student, the second student, the third student, you have 10 students you like to store, you might need to have 10 string variable, 10 string metric, and 10 string for phones. You can use phone 1, phone 2, phone 3, phone 4, phone 5, but you get the idea. Yeah, so the sane solution is to use array. So to use array in programs, so for example, I would like to use name to store the information. So you need to define the array itself, and then you need to have the array size. Let's say I would like to store 5 or just 3 student information. Okay, so let's say I would like to store 3 student information. So I need to create first the variable array called name, and then set the size to 3, and it goes the same with the rest. For metric, also 3 students, and for phone, the same. So if you like to request 3 student information, so you need to store this one by one. So if you like to print out the information, something like this. So this is only for first student. So if you like to have more than, you want to print out 3 students, so you can use this as the second student, name 1, array 1, array index 1. And then if you like to print out the third student, index 2, that will basically store student information. And then if you like to print out the 3 student information that we just assigned to, array 1 and then array 2. We have 3 students, we have 3 array. Alright, so now we are able to store information for 3 students in our application. Anis, street number 1, 2, 3, 4, 5, phone number and the student name, John, metric number, phone number, and the third student, Ali, metric number, phone number. Right, and then the system will print it back. the three information that we store into array. And of course, we can use our for loop here to store the information using for. So if you like to do that, that can also be done using if statement here. Sorry, for statement, for loop to make it easier for the programming. For integer I equals 0, I is less than equal 2, I plus plus. Then we can put everything from here inside here. If not, you can just use less than 3 because the size of data is 3. So you have 0, 1, 2. Like to run this in for loop, so you can use the following. For loop, okay, the size of data is 3, and then you can enter 3 data and print back the information to user based on the array index. So if you have more data, you have more student information that you like to store, and then you are going to have more complex data management using, for example, array. So imagine that this is just for 3 data. If you grow this, if you increase the size of data, you can see that the data is getting more and more complex. Even though these 3 array that we built here, they are supposed to correlate to each other because we are storing information on the students. So the array index here, for example, name index 0, metric index 0, and phone index 0, they are related to each other. However, in terms of managing the data, for example, if you like to delete the information, or if you like to update the information, or search the information, that is going to get tricky. There are no cohesion, there are no relation in the programming itself, except that the data is being stored in array. Okay, only the cohesion of the data is based on the index number. Okay, so and it get more complicated later because the storing of the information in a procedural data structure or in the procedural programming, it will get messy when the data grows. So you can imagine you have 100 data or 200 data, 1000 data, and for UUM we have like 30,000 students in UUM, and we like to store all those information, we like to manage all those information. It's get really tough. It's going to get messy in the programming itself. That is how structured programming works. Okay, so we break our problem into a sub method or sub procedure. So even you can see from this here, we have 2 methods now. The first method is the main method always, and then we have the public static void main as our method. Okay, so we break our program into a much more manageable procedure. So you can have like some other method, static void search student. Okay, so you can use string metric for the search. So you need to implement your search procedure or search algorithm here. So you can use for loop, or you can use based on the names, phone number. So that depends on how you break your program, how you design your program. But still, we break the program into a more manageable solution. So this is not basically the only way. There's a lot of other ways. So this is just some example. You can also divide the program into a much smaller pieces. Okay, so for example, when we print student information, so all the print request is inside here. If you like to search student, all the method is here. So inside our main method here, there's only calling of the program, or you loop the program based on the needs of the program itself. But at the end, you know that this is basically how structured programming or paradigm works. Okay, so you can break this. You can have your main program here. You can have your static method here, as many as you like, when we break it down into smaller pieces. So the separation of data and the procedure that operate on data can lead to problem as the program become larger and become complex. Okay, so when you have more data, more variables to handle, it get messy, it get very complicated. So you have more like thousands array here, thousands array there. Managing that kind of data is going to be very, very headache. So that's why we have ourselves an object-oriented approach. So an object-oriented approach is basically identifying or translating real-world object into the programming itself. We identify when we have a problems that we like to develop into a programming solution. We need to identify, we need to break, instead of breaking this into a sub function, sub method, we break it down into object. Okay, a more realistic way of looking at a problem, because our real world problems is object based. When we look around us, there's a lot of object here and there. Okay, so for example, inside our class, the object that we are seeing inside our class is, for example, computers, chairs, desk, the electrical appliance inside the class. So all those object is an object. When we define it, object is an object, something that we can touch, something that we can identify its characteristic, something that we can see, we can look into, we can identify into, because that is basically how we are seeing our world. So the world itself is being translated, the object itself can be translated into programming. So identify object from the main problem. So we have a problem and then we like to translate that problem using object. That's where the name of object-oriented programming comes. So an object-oriented programming is a collection of objects that interact with each other to solve the main problem. Okay, so we look at even ourselves, you as a student, you as an object of reference in a programming or in a problem, for example, storing student information. So the programming look at you as an object. So as an object, you have your own characteristic, you have your own variable, you have your own value that we can store, identify. So they can interact to each other. This object can interact to the other object, and then they can be very useful in solving the main problem. So each object is a software entity that contains both data and procedure. This is very important in object-oriented programming. Each object that we identify contains these two, data and procedure. Okay, so very, very important. So you need to be able to identify this. Okay, what are the characteristics, or the other word is data, and also what are the behavior of that object, and we call it as a procedure. So data and procedure. So object-oriented programming more or less is a natural way of solving problem, because when we treat object in a software, it basically represents the real world. It represents the real thing. So for instance, a program in university student information would have different object to represent. So you can identify student, lecturer, course, schedule, etc., etc., etc. So when we treat this object in the software as it is, the type of object handle and processing becomes easier to handle, because when we look at one object, that object contains all the information needed. So if you like to apply data processing to that particular object, it only applies to that particular object, not the other object. Okay, so that's how object-oriented programming works. In the procedural, all these functions, a related function is being grouped together. Okay, so it's grouped, but it didn't take the object into its paradigm, into the idea of breaking down the program. So to withdraw, to deposit, to transfer, all this related operation is being grouped together and then executed. However, in object-oriented programming, the object itself manages its data and its operation. Okay, so what kind of operation can be done to the object itself? What kind of data can be stored to the object itself? So that is procedural versus object. You really need to take this into, you really need to be able to identify the differences. So more details on object-oriented programming. So in our daily world, we use object. We use when we drive, for example, when I come to the school, to work, I drive the car. The car is an object. When I use my computer is an object. When I talk to student and lecturer, both are also object in a real world. So it's a thing. It can be tangible, something that can be touched, something that can be seen, something that can be, a hard item. Or it can also be intangible, something that you cannot see it. It doesn't exist in the real world. However, it basically exists in a more abstract way. For example, your bank account. Okay, so your bank account is an intangible item or intangible things that can be defined. It has its own characteristic. It has its own behavior. But you cannot touch account number. Okay, of course you can have the account number written, but that is something that intangible, something that cannot be a physical thing. So a software object represents real world object by having these two representation: data and behavior. Data is a variable, is an attribute or the general characteristic or descriptive characteristic of that object. For behavior, it's a procedure or its methods operation for each object that can be done towards the data itself to store the information about the data that defined here. So you have these two very, very important characteristic or very, very important representation of object. They are going to have these two things: its state and its behavior. States behavior. Alright, so for example, your bank account. Okay, so when we define as a bank account, so your bank account can have these two components, the state and also the behavior. So the state identify the object itself. For example, the account number, or current balance, owner names. So all those that define the account number is going to be defined as variable. The behavior of that bank account number is that, so you need to define it as to do what? To do what to the account number? Okay, so you are able to deposit, you are able to withdraw, you are able to check balance. So those are the behavior associated with the bank account object. And the behavior of an object might change its state. It can change the value. Okay, the value can be changed. For example, if you withdraw money from your current account, the current balance can be deducted and it can change its value. Okay, so those are the two things that very, very important for us to identify. So when does classes comes from? So when you define any object-oriented programming or component to the object-oriented programming, you need to find out the object that is a must. All related objects in your program must be identified first. Okay, so for example, if this program for student, okay, you like to develop program that stores student information, you need to identify what are the objects related to this program, and of course and obviously student. Okay, so you have this student A, student UEM student. Okay, for example, you like to store data on UEM student. However, object is a unique identification. Means that for an object to exist, you can identify that object. You can pinpoint that is an object. However, in a programming, you cannot create object out of thin air. The object must be defined first. The object must has its description, a general description for it. And this general description can be defined through classes. Okay, you cannot create object out of thin air. You cannot just define an object in programming. There's no way you can define an object without having a class. So, a class is a general representation of an object. It's a blueprint of an object. Okay, student A, student B, student C, each and every one of the students, they have their own metric number, they have their own names, they have their own phone number, etc., etc. So it means that for each student A, B, and C, we can pinpoint the student itself. So that is an object. However, 3 of these students, they belong to the same classes called student. Okay, student. So we, in a programming, object-oriented programming, we need to define all of this into one, what we call as class. And this class will define its general states and also its general behavior. Each object that is created from a class is called an instance of a class. Okay, so remember, when we created object in our programming, we are created this, or we are instantiate the object from a class. Multiple objects can be created from the same class during program execution and store it in the main memory. So let me show you a simple example how this is being done. So let's say this is the same program, and I'm going to use object-oriented programming for this program. Okay, so first I'm going to remove all the program first, and then also the same with this, all the variables and everything, leave it empty. So next I'm going to create a class, because I want to develop student information system, the same three information that I would like to store. So I need to create a new class called student. Okay, now you can see inside this package, it contains another file called student.java. So this is a public class student. So as I mentioned before, there are two characteristics that you need to be able to define as a class. The first one is a variable. So we have three variables defined: name, metric, and phone number. So these are the three variables. And we like to, if you like to store the information on the student itself, this is generic, because we don't define the student names here. We do not do this. Okay, we do not do this in a class, because a class is a general representation. So you do not do this. Okay, you do not do this. You don't store information inside your class. If you store information, it must be either a constant data, means that the value remain the same. For example, value of pi. That is the only variable that you can somehow store. But for a class to work, it needs to be able to define as a generic representation. So for a student, you have name, metric, and phone. And if you like to print out the information of the student, so void print info. Okay, so this is to print info, system.out.println name plus name, and then we like to print out 3 metric and another one phone number, metric and phone number. And you would like to also store the information, void store info or save info, whatever you like to call it. So string n, string m for metric, and string p for phone, and name equal n, metric equal m, and also phone equal p. So this is where we initialize the value. Student save information. So we have two methods available now. One method is to print out the student information. The other method is to save the information, or you can give it another name, insert data, for this method. Okay, now although this is not what we call as a proper class, but it embodied the structure of a class. So you have your class name, no data at all. You don't store data here. You don't store data here. Sorry, insert data. You store data from a creation of an object. So we don't have object. We only have a class, a general class for the student. How do we create object? It's inside here. Okay, so the way that you create an object here, or what we call as a user-defined object. I know this is quite advanced because we're going to look into this later, user-defined object. So to create object, so of course at first we need to use scanner class because the data comes from here. If you like to, or you like to have that data print out from the student.java, also can. But normally we store our data in our main program. So scanner scan new scanner system.in. Okay, so we're going to request for okay, so request for student name, request for student metric, and then the third one, request for student phone. Right, now we requested the data, 3 data. How do we assign the value to data to the object? The first thing that we need to do is to create the student object. So we already have the student class. It must be within the same directory. It cannot be outside directory. So you need to make sure that this student.java must be inside the directory. Okay, so to create the object, so the way that we define it is the name of the class, object name, let's say stud1, the first student, one student only, new student. All right. Now, this is basically an object, stud1, student1. So it is an instant of the class. So instant of the class, this is instant of a class student. And we have stud1 that will store these 3 information inside the object. So how do we store it? How do we store the data? We're going to use this insert data. How do we call it? Easy. Stud1 dot insert data. What are the data you'd like to insert? Name, metric, and phone. There are 3 data that you like to insert: name, metric, and phone. So it will basically store into name, metric, and phone for the object stud1. So if you like to print out, you can just call stud1 dot print info, so that it will call this method print info that will print back name, metric, and phone for the object stud1. So if you run this program, Anis, student metric number, phone number. So it turned out to be exactly the way that, even though it basically the same output with the first one that I've shown you before, but it basically embodied the idea of having object-oriented programming. Okay, so the idea of having object has been introduced in this example. So if you like to have student number 2, you can always just set a new object called student2. Now the student2 has been successfully created. However, if you like to store information about student2, you need to request again from user what kind or the 3 information needed. Okay, because at the moment student 2 contain no information. So if, for example, if you like to print out student 2 information, it should print out nothing. Okay, because there's no information for student 2. Let me try to show it to you. So the first student, Hanis, metric number is this, and this is the phone number. So this is the printout for the first one, and this is the printout for the second student because it contains no data. We try to print out no data because we didn't insert any data. There's no variable, no behavior that we use to insert the data. So if you like to insert the data, you can also use this same program up here, request this again, and repeat the process all over again. Okay, since the variable already been defined, we need not use that. Okay, so you can just always again insert the data for the second student. So instead of student 1, we use student 2. Okay, now you have 2 students to be able to insert into this program. Phone number, and second student, Jack, entry number, and phone number. So you have 2 students print out here, 1 and 2. So even though it is basically the same with the first one, however, the idea of object-oriented programming has been laid off here. This is basically the idea, the changes that you need to make whenever we decide to write a program in Java. You need to identify the object first and then come out with a class that defines that object. Okay, you can create multiple objects as I created here. There's a 2 object, 1, 2. Okay, so 1, 2. There's 2 objects created here. Alright, so the differences. A class is a piece of program source code. Okay, so a piece of program code. This is a class. A piece of program code. It contains no value. It contains no exact value. It only laid out the blueprint, the generic representation. There's no value here. Okay, you don't have name, metric, phone number. You can only assign this value through the creation of object. An object is an entity, a running entity. Okay, because when we created an object here, this is an object. Stud1 is an object. This is a running entity. Without the class, you cannot create object. Object cannot exist without class. Again, object cannot exist without class. Written by programmer, so of course, the class is written, the code must be written, a generic representation. Created when the program is running. Okay, it can only execute it if the program is running. This object created when the program is running. Alright, so another example here. We identify, for example, if you like to develop program for dog. Okay, the class name is dog. The variable for the dog identified name, age, either the dog has been getting their shot or not, has shot or not. Method, to change the variable up here, change name or update the shot value. Okay, this is the method. So normally the method is being used to update or change the value here or do some operation. The object that we refer here, you can see now the object is very, very intimate, very specific. Spike, the name, 4 years old, has short yes. Brutus, 7 years old, has no short no. Okay, so this is specific. When we talk about object, it is very specific. You can point your finger to that, it is an object. You cannot point the finger, that can be a class, okay? Or even a generic representation of multiple object is a class. How do you draw? So in programming, you need to define this, what we call as a class diagram. So when designing a class, it is often helpful to draw UML. So when we define a class, we can define using UML class diagram. We call it UML class diagram. It consists a rectangle. So you can see now this is a rectangle with three subdivided sections. A top section contains the class name up here. The middle section contains the variable, the data type identified. And the last section contains the method name. So this is basically the way that we write our UML diagram. So for example, we identified a class called employee. So the name must start with capital letter at front because all the class must started with capital letter. The variable, okay, when we define variable, we need to define the data type. This is number, this is number, this is string. And the variable always start with a lowercase and middle and uppercase in the middle for the second word, and it cannot contain any spaces and whatnot. The method, so this is basically the way that we write the method. Okay, so set last name, so you like to set the last name. This is the passing argument, and this is the return argument. Pass, return. Okay, so for example, in my example here, if I like to write this, this is void. Void means return. Return nothing. I don't have to write anything. The return is void. And the passing value here, so since I contain three data, string n, m, and p, so I need to pass three variable here. Okay, so that is basically how you write your UML diagram. All right, welcome back. So for this class, we're going to look into 4 unique characteristics of an object-oriented programming. So I hope by now you'll be able to change the mindset now, moving away from the structured programming to the object-oriented programming. So in OOP, we have 4 unique characteristics of OOP. The first one is abstraction, second one is encapsulation, the third one inheritance, and the last one is a polymorphism. So we're going to look into this in a general way first, and because later we're going to have for each topic here its own detailed description how each of these will be implemented. So the first one is abstraction. So an abstraction focuses upon what we call as an essential characteristic of an object. So when we look at the object itself, from different viewer perspective, they process a different value or different characteristic. So the process of showing the essential detail or features of an object and hiding its complexity. So when we created object out of a class, it is basically an abstraction of a real world object. Okay, so for example, a cat is an object. A book is an object. A car is an object. However, the detailed implementation or the definition of that object has been hidden inside the class itself. And also it takes also a different abstraction coming from a different viewer. So for example, if you can see from this picture, a cat perspective from a grandma is a lovely cat. Okay, she like to purr, she's beautiful. So those kind of representation is different from different viewer. From this penetration, from this cat doctor here, veterinarian, the view is from the science perspective. The heart, the kidney, the bones, all the health related, or the structure of the cat itself, look or viewed from her perspective. So the implementation is being hidden or is being abstracted. It's being abstract and is being hidden for that. So when we define a cat from a cat class, we don't have the implementation of the cat because it is being hidden inside that object. For encapsulation, okay, so process of combining all the object and method into class. So once we define a class, okay, we are defining the general representation of an object. So the data are frequently hidden from outside. So normally we don't define data as a public. We hide the data through the use of public keyword and can only be accessed through methods. So the concept of encapsulation, we hide the data. Okay, we don't show the data. It is supposed to do that. For example, for this class. So for this class, I should define this as a private. Okay, so that the data can be hidden. If I didn't define this as a private, I can access this easily from here. For example, stud1 dot. You can see that I can access this name, metric, phone number easily from this class. Okay, so I can easily modify the value here. Stud1.name to a different name. However, if I hide the data through the use of keyword private, now the data cannot be accessed. You can see dot. I don't have name inside here. Okay, no longer. So thus the hidden of the data from outside classes while method are accessible. So the only way that to access the data is through method, through the modifier. Okay, through the what we call as a getter and setter method. Okay, so the concept that other classes should not alter object attribute. Only the object method can do that. That is what we call as a privilege. An object protect and manage its own information. Okay, so for each object here, stud1 manage their own name, metric, and phone. No other way that this class, the main class or some other class that instantiate stud1 can modify that value. So that is data hiding and data protection defined here. And compared to the first one that I've shown, the use of array, they are loosely connected data. Here they are tightly coupled data. They are grouped together. Stud1 with this very specific name, with this metric number, with this phone number. Stud2, Stud3, Stud4, go so on with their own data. So they protect their own data. They manage their own data through the use of method, constructor, and also variable. So to keep data accessible to outside class, we define as a private. So as I'm shown here, we define the variable as a private. You can no longer access that value outside. You can only access through the method. So to make method accessible, we define as a public. And in UML class diagram, a minus is indicate that it is a private and a plus is a public. So if we update our, for example, UML diagram for employee, variable will always define as private, negative, negative, negative here. For method, most of the time we define this as a plus, as a public. Whenever we set the value or we get the value, you can see here set and get. So whatever setter and getter method that we modify the variable inside this, we always define this as a public, unless there's a method inside here that needed to be defined as a private. So for example, this is a method that can be only called within the employee class itself. The next characteristic of OOP is inheritance. So inheritance is basically a concept that allow a child class to be created from another class. Okay, so a class can inherit another class. So you can extend the use of other bigger class. Okay, so you can have multiple subclasses defined in Java, particularly in Java in OOP, so that you don't have to. You can share the codes. You can share the parent class with some other class that can be identified as subclasses. Okay, so this is what we call as inherit. We're going to look into this detail later. For example, here we can define a generic class called person that contain first name, last name, and date of birth. And we can create another class called student and employee that inherit this parent class. Okay, student is a person. This is what we call is a relationship. Student is a person, employee is a person, and both of student and employee inherit person class. Okay, we can define this and it can be shared from student and also employee, so that we don't have to rewrite first name, last name, date of birth for student and also date of birth, first name, last name for employee. So it can be what we call as a shared classes. Finally, for polymorphism, this is quite advanced concept. The term polymorphism means that we can change the object from one form to the other form. Okay, allow you to create method with the same name but with different implementation classes through the use of inheritance. It needed inheritance to be able to implement polymorphism. The ability to call the correct method depend on the type of object that it's used to call it. Okay, so for example, we can define a method called open, and this method can be used to open door, can be used also to open bank account, and also can also be used to open eye. We're going to look into the detailed implementation. The idea is that you can have shape with method draw and erase. However, when the draw implemented by circle, it draw a circle. When draw implemented by square, this is inheritance because circle is a shape, square is a shape, triangle is a shape. And there's a method inside here, draw shape. And you can also draw shape here. However, if it is being called draw from circle, the draw takes shape of circle. When the draw is being called by square, it will implement square draw, and if the draw is being called by triangle, it will implement draw triangle. So that is basically basic introduction to OOP and conclude topic 1. So I hope that you can utilize this online video. If you have any problem, you can ask during the class. So we're going to have some basic understanding of basic programming and basic comparison between structured programming and object-oriented programming discussion in our class. Alright, so I'm looking forward for the next online class session. With that, thank you and happy coding.